Want to bridge a local MCP server with DSPy's agent system in just a few lines? You'll see how to launch a Python subprocess as an MCP server, connect to it via stdio, and wire its tools directly into a DSPy ReAct agent. The example will ask a simple math question and route it through the local server for processing.
Import stdio. Import DSPy. From MCP import client session, stdio server parameters. From MCP client, stdio import stdio client. Async def main. Hash configure the stdio server. Server params equals stdio server parameters. Command equals Python, hash command to run. args equals path slash to slash your slash MCP server, pi, hash server script path. env equals none, hash optional environment variables. Hash connect to the server. Async with stdio client, server params as read write. Async with client session, read write as session. Hash initialize the session. Await session initialize. Hash list available tools. Response equals await session list tools. Hash convert MCP tools to DSPy tools. DSPy tools equals DSPy tool from MCP tool session tool. For tool and response tools. Hash create a ReAct agent with the tools. Class question answer DSPy signature. Answer questions using available tools. Question str equals DSPy input field. Answer str equals DSPy output field. ReAct agent equals DSPy ReAct. Signature equals question answer. Tools equals DSPy tools. Max iters equals 5. Hash use the agent. Result equals await ReAct agent, a call. Question equals what is 25 plus 17? Print result answer. Hash run the async function. Asyncio run main.
This demonstrates the tool integration pattern for connecting external tooling systems with agent frameworks. The code establishes a local process connection to an MCP server, discovers available tools through protocol introspection, and adapts them for use within a DSPy ReAct agent. The distinctive aspect is how it maintains tool functionality while changing only the execution context. The pattern follows a clear sequence, first creating a stdio transport to a local Python process running the MCP server, then using the session to enumerate available tools, and finally converting each discovered tool into DSPy's native format while preserving its original parameters and behavior. The conversion process handles the protocol differences transparently, allowing the agent to invoke tools through a standardized interface regardless of their origin. This approach enables direct reuse of existing MCP tools within DSPy agents without requiring changes to either system. It solves the common integration challenge where tools from different ecosystems need to work together, providing a clean bridge between MCP's protocol-based tools and DSPy's agent-oriented programming model. The pattern is particularly useful when you need to leverage existing tool implementations while building agents in DSPy. Let's break it down.
Import asyncio. Import DSPy.
Imports asyncio for asynchronous execution and DSPy for the framework's core functionality. These are the foundational dependencies for the async operations and agent creation shown in the script.
Async def main. Hash configure the stdio server. Server params equals stdio server parameters. Command equals Python, hash command to run. args equals path slash to slash your slash MCP server, pi, hash server script path. env equals none, hash optional environment variables.
This defines the async entry point main, and configures server launch parameters using stdio server parameters. The three key settings, command, args, and env, specify how to start the subprocess, but note that this only prepares the configuration. The actual server launch happens later in the stdio client. Call.
Hash connect to the server. Async with stdio client. Server params as read write. Async with client session. Read write as session.
Double context manager pattern for connection handling. The outer stdio client manages the low-level stdio connection using the server parameters we configured, while the inner client session wraps that connection in MCP's protocol layer. Both use async with to ensure proper cleanup when their blocks complete.
Hash initialize the session. Await session initialize.
Establishes the initial handshake with the MCP server. This async call prepares the session for subsequent operations like tool discovery and execution.
Hash list available tools. Response equals await session list tools.
This fetches the list of available tools from the MCP server using session list tools, storing the response in the response variable. The return data contains the tool definitions that will be processed in subsequent steps.
DSPy tools equals DSPy tool from MCP tool session tool.
Converts each MCP tool from the server response into DSPy's tool format. The from MCP tool class method handles the protocol adaptation between the two systems.
Class question answer DSPy signature. Answer questions using available tools. Question SDR equals DSPy input field. Answer SDR equals DSPy output field.
This creates a DSPy signature class that strictly defines the input-output schema for our agent. The question, input field, and answer, output field with type annotations form a contract that the ReAct agent will follow when processing the math question we provide later. It's the blueprint that keeps the agent's execution focused on transforming questions into answers.
ReAct agent equals DSPy, ReAct. Signature equals question answer.
This instantiates a DSPy, ReAct agent using the question answer signature to define its input-output schema. The signature specifies that the agent expects a question field and must return an answer field, enforcing a strict structure for the agent's interactions.
Result equals await ReAct agent, a call. Question equals what is 25 plus 17?
This invokes the ReAct agent's async, a call method with a math question as input. The method executes the agent's reasoning loop once, returning the computed answer in the result object.
Hash run the async function. Asyncio run main.
This executes the async main function by creating and managing the event loop. Asyncio run is Python's standard way to run top-level coroutines, handling the event loop lifecycle automatically. Async MCP client pattern. This code demonstrates a complete async workflow using stdio client to connect to an MCP server and client session to manage the protocol interaction. The question-answer signature strictly defines the agent's input-output contract, while tool conversion happens through DSPy, tool, from MCP tool for each discovered MCP tool. Every MCP operation from initialization to execution requires explicit await calls, making async flow control visible at each step.
The schema that describes everything describes nothing.